In the previous class, in session 1, we already learnt about the different types of the numbers, variety of the numbers we already discussed in the previous classes. For example, natural numbers, whole numbers, integers, and real numbers. We are classifying into two types, that are rational numbers and irrational numbers. Rational numbers means the numbers which can be represented in the form of p by q or a by b or in the form of x by y. In that, the denominator is not equal to 0. It means if I am representing any number in the form of p by q, where q is not equal to 0, q is not equal to 0. If q is equal to 0 means we cannot define the exact value, right? It is infinity. So these kind of the numbers are called as rational numbers, and we already discussed some properties of the rational numbers. So properties means in rational number the denominator is not equal to 0, and the sum of any two rational numbers is always rational. The subtraction of any two rational numbers is always rational. The multiplication or division of any two rational numbers is always becomes a rational number only, right? And we will discuss some problems, simple problems. We write the rational numbers between the two given numbers. In that, we already discussed three methods, right? So in this session we will discuss about the same concept, that is write the rational numbers between. Here I am taking two more examples to the similar session only. Write the rational numbers between 2.6 and 4.7. Write the rational numbers between 2.6 and 4.7. So these two numbers are the given numbers. In that, you need to write the rational numbers. I already told you in the first session, you can write infinite number of rational numbers between any two numbers. If I am giving 0 and 1 means in these two numbers also you can write infinite number also. For example, 0.1 or 0.00, 0.01 or 0.001. If I write start from 0.1 means 0.2, 0.3, 0.4, 0.5 like that, right? 0.2, 0.3, again that is 0.11, right? 0.12. So we can write infinite numbers. You can, if we are giving two numbers means, if we are taking any two numbers means, in that two numbers we can write infinite rational numbers between any two given numbers, right? So write the rational numbers between 2.6 and 2.6 and 4.7. Just multiply 10 on both sides. Multiply, or the denominator of these numbers is always 1. 4.7 divided by 1, right? If the denominator is 1 means just multiply 10 for both numerator and denominator. We already discussed these are questions in the previous classes. So once I multiply 10 to both numerator and denominator, what I will get? 26 by 10 and 47 by 10. Now I can easily write here the denominators are same. There will be no need to multiply any number because we have some numbers which are existing between 26 and 47. So the rational numbers between 26 and 47 are 26 by 10, 27 by 10, 28 by 10, 29 by 10, 30 by 10, 31 by 10, 32 by 10, like this. Or we can also write 2.6, 2.7, 2.8, 2.9, 3.0, 3.1, 3.2. So these are the sum of the rational numbers which are existing in one given two particular numbers. Here the two particular numbers are 2.6 and 4.7. So in these two given numbers we can write infinite number of rational numbers. So these are the sum of the rational numbers which are existing in between 2.6 and 4.7. okay. Next, in this, the next concept is terminating and non-terminating, or the decimal representation of the rational numbers. Decimal representation of the rational numbers. Decimal representation. Decimal representation of rational numbers. Rational numbers. So decimal representation means what? We are representing the p by q in the form of the decimals, right? So in the decimal representation we have two more concepts, that is the terminating decimal expansion and non-terminating decimal expansion. Terminating decimal expansion and non-terminating decimal expansion. We will discuss one by one. The first one is terminating decimal expansion. Terminating decimal. Terminating decimal expansions or terminating decimals. So terminating decimals means what? If I am taking 2 by 5 by 2 means 5 by 2, it is in the form of p by q, in that q is not equal to 0, right? So it is a one of the rational number. 5 by 2 is a one of the rational number. It is in the form of p by q, where q is not equal to 0. It means here the q value is 2, right? So if q value is 2 means you can easily divide the numerator by using denominator. So the basic method, in the division method, just divide the 5 by 2. 2 2s are 4, right? What I get remainder here? 1 is the remainder. Take here point. If I take here point means it becomes 10. 2 5s are 10. 2 5s are 10. The quotient, what I get the quotient here? This one is the dividend, divisor, quotient and remainder. This is remainder and this one is the quotient. This is divisor and this one is the dividend, right? You already learnt in the previous classes. Here terminating means whenever the fraction or a rational number in the form of p by q, when we are simplifying that rational number, that will be completely terminates. It means there will be no remainder left. Here the remainder is 0. So these kind of the rational numbers are called as a terminating decimal expansions. This quotient, what we are getting quotient now, 2.5 is the terminating decimal, terminating decimals, okay. So every fraction, each and every fraction or each and rational number we can represent in the form of terminating or non-terminating. We will discuss the non-terminating in the next concept, okay. Now for example, here I am taking some examples for terminating values. 1 by 4 which is equal to 0.25. Second one, 5 by 8 which is equal to 0.625. Okay, next third one, 2 by 2 integer 3 by 5. 5 2s are 10, 10 3s are 13. 13 by 5 is nothing but when we are subtracting, when we are dividing these two, we get 2.6. And next one, third one, 7 by 8. 7 by 8. When we are dividing 7 by 8, what we will get? The decimal expansion as a 0.875. Next, fifth one, 35 by 16. 35 by 16. When I am dividing 35 by 16, I will get 2.1875. So these are the some examples I am taking for the terminal decimal expansions. Terminal decimal expansions means they are completely dividing numbers. When I am dividing the numerator with the help of the denominator will divide the numerator completely without leaving any remainder. So these kind of the coefficients, what were getting coefficients, no? So these kind of the coefficients are called as terminating decimals. Terminating decimals. Okay. Terminating decimals, one important concept related to terminating decimals. How we are going to be now, whether the given rational number is terminating or non-terminating. One simple method is there. Here I will take examples, right? But if I am taking randomly some numbers, 21 by 20, 20 by 30, or 47 by 58. So these are the some rational numbers, right? Or these are the some fractions. Now these fractions, how we are going to be identify whether the given fractions or given the rational numbers are terminating or non-terminating. The rational numbers which are in terminating when the coefficient or the denominator, the rational number is in the form of p by q, no? The q should be the factors of prime factors of 2 or 5. Can I take one example? These are the some examples for the terminating decimals. So terminating decimals means what? The numerator is exactly divisible by the denominator without leaving any remainder. What we are getting coefficient, no, that coefficient is a terminating decimals. Terminating decimals. Okay. Now I will take one examples. 21 by 40, 21 by 125. 21 by 125. 21 by 125. Is it terminating or non-terminating? Means first we should factorize the denominator. What is the denominator value? Denominator q is equal to, it is in the form of p by q. 21 by 125, it is in the form of p by q, where q is equal to 125, right? We need to factorize 125 with the help of the prime numbers. 125. Factorize the given number. 5 25s are 5 5s are 5 1s are. So this 21 by 125 can also be written as 5 cubed. So if denominator of the rational number is in the form of, if the denominator of the rational number is in the form of 2 raised to n or 5 raised to m, either it is in the form of 2 raised to n or it is in the form of 5 raised to m, these kind of the rational numbers are completely terminating decimals. I will take one more example. Second one, 28 by 40. So again it is in the form of P by Q, where Q is equal to 40. So just take the decimal prime factorization of 40. 2 20s are, 2 10s are, 2 5s are, 5 1s are. Now the 28 by 40 can also be written as 28 by 2 raised to 3, 1 2 3, 2 raised to 3 into 5 raised to 1, 5 raised to 1. Here the denominator Q is in the form of 2 raised to n and 5 raised to m, 5 raised to m. Okay. Now we'll take one more example. Then after this example I will compare just whether the fractions are in the form of terminating or not. Third example, 27 by 8. So again it is in the form of P by Q, right? Q is equal to 8, factorize the 8. Once I factorize the 8 means 2 3s are, 2 4s are, 2 2s are 4, again 2 1s are. So 27 by 8, that can also be written as 27 by 2 cube. Fourth one, 14 by 15. It is in the form of P by Q, where Q is equal to 15. So factorize the 15. 3 5s are, 5 1s are. So 14 by 15 can also be written as 14 by 15 can also be written as 3 into 5. Now observe these all 4 examples. This is the first example, second one, and this one is third one, fourth one. In first example, what we are getting in the denominator? 5 cube. In second example, after the prime factorization, we are getting 2 cube into 5 raised to 1. 2 cube into 5 raised to 1. In third example, we are getting 2 cube only. In fourth example, we are getting in the place of denominator 3 into 5. So, how we can identify whether the given rational number is terminating or non-terminating? Listen here. In the given fraction or in the given rational number, the denominator, it means the Q value, is when we are factorizing the denominator, if it is in the form of 2 raised to n and 5 raised to m, 2 raised to n and 5 raised to m, then that numbers are completely terminating numbers. Whether it may be in the form of 2 raised to n, it may be in the form of 2 raised to n, or it may be in the form of 5 raised to m, or it may be in the form of both 2 raised to n and 5 raised to m. If I am getting other than these numbers 2 and 5, that is the example for non-terminating. Clear? In first one, the denominator is in the form of 5 raised to m, where m and n are the any natural numbers, any positive integers. You can take any positive integers here. It may be 1 or 2 or 3 or 20, 40, 50, whatever it may be. N and m are the positive integers. Okay. So in first example, when I am the denominator of the first rational number 125, when I am factorized with the help of the prime factors, I will get as a 5 cube. So 5 cube is a one of the form of the terminating. So this number will be completely terminating. This number will be completely terminate. We will discuss in this session only. We will discuss some problems like this in this session only. Now in second question, 40, 28 by 40, 40 is the denominator value. When I factorize that 40 with the help of the prime numbers, I will get as a 2 cube into 5 raised to 3. Again it is in the form of 2 raised to n and 5 raised to m. So it is also a purely terminating value. Next, come to third one, 27 by 8. In that the denominator value is 8. Denominator value is 8. So denominator value is 8 means when I factorize the 8 with the help of the prime factorization, I will get as a 27 by 8 can also be written as 2 cube. 8 can also be written as 2 cube, right? So this 2 cube indicates this is also a purely terminating decimal values. It can purely terminates. The 27 by 2 raised to 3 is a one of the exactly divisible number. Next, come to the last one, that is 14 by 15. Again it is in the form of p by q. In that denominator value is 15. Denominator value is 15. When I am going to be factorized with the help of the prime factorization, I will get as a 3 and 5. Yes, I have 5 here, but I have one more number, that is 3, which is other than 2, right? So once I get any number which is other than 2 or 5, that kind of the numbers are non-terminating. Clear? Now we are getting some ideas. You are getting some ideas based on the terminating expansions. A rational number, if a rational number in that denominator is in the form of 2 raised to n or 5 raised to n, or in the form of 2 raised to n and 5 raised to m, then that kind of the rational numbers are purely terminating rational numbers. If we are getting other prime factors like 3, 7, right? Next one, 11, 13. If you are getting other than 2 and 5, these are the prime numbers. No, 2 and 5 are the prime numbers. If you are getting other prime numbers other than these two, then that rational number is considered as a non-terminating. Okay, so this is the easiest method to identify whether the given rational number is terminating or non-terminating. Okay, now we'll take some examples. With the help of these examples, we'll understand how the rational numbers is terminating and non-terminating. Without doing actual calculation, how we are going to be identify whether the given rational number is terminating or non-terminating. Okay, see the first question, 21 by 40. 21 by 40. The given question is represent the rational number in the form of decimals and check whether the given rational number is terminating or non-terminating. Terminating or non-terminating. Okay. So before going to be solve this one, first it is in the form of p by q, and that q value is 40. First find the prime factorization of the denominator, that is 40. Denominator value is 40. Prime factorize the 40. So 2 20s are, 2 10s are, 2 5s are, 5 1s are. So this 21 by 40 can also be written as 21 by, how you can write that 40? 40 can also be written as 2 into 3, 2 raised to 3 and 5 raised to 1. 1, 2, 3. 2 raised to 3, 2 cube into 5 raised to 1. Okay. So 40 can be written as 2 cube into 5 raised to 1. Now, we can equate the powers of the 2 and 5. Whenever we are going to be represent the rational number in the form of the decimal expansion, first we will equate the powers of 2 raised to n and 5 raised to n. It means it is in the form of 2 raised to n and 5 raised to m. No, we make m is equal to m. We make it as a n is equal to m. How we are doing this one? Here 2 raised to 3 is already there. 2 raised to 3 is already there. 5 raised to 1 is there. Now, what is the remaining value to need to equal 3? Means we are multiplying the one more term, that is 5 raised to 2. 5 raised to 2. The same number should be multiplied for the numerator also. When we are multiplying the same number for numerator and denominator, it will not affect the given fraction. For example, if I am taking here 3 by 2 by 3, if I multiply 10 for both numerator and denominator, what I will get? 20 by 30. 20 by 30, it is nothing but 10 2s are, 10 3s are, again I will get it as a 2 by 3 only, right? So, when I am multiplying any number in the rational number for both numerator and denominator, it will not affect the original rational number. Okay. Here 21 into 5 square means 25. 21 I write as it is. 5 square means 25. 2 cube write as it is into. Here in these two bases are same. When the bases are same, the powers can be added. We already know the exponential laws. A raised to m into a raised to n. Here the bases are same. When the bases are same, powers can be added, means a raised to m plus n. Like that, 5 raised to 1 into 5 raised to 2. Again here bases are same. I write base as it is, and now I am adding the powers of these two exponents. 1 plus 2, that is equal to 5 raised to 3. 5 raised to 3. So 21 into 25, 5 raised to 3, right? So 2 raised to 3 and 5 raised to 3. Again it is in the form of one more exponential law we are using here, that is a raised to m into b raised to m. A raised to m into b raised to m. Here the bases are different but powers are same. When the powers are same, we multiply the bases only. In first exponents, when the bases are same, we add the powers. In second condition, when the bases are different with common powers, these two are the common powers, no, m and m. So in this case we are multiplying the bases. So a into b raised to the power m. So how you can write this one? First multiply 21 into 25. 21 into 25. Multiply these two. 25 ones are 25. 2 carry, right? 25 twos are 21 ones are 20. 25 ones are 25. 2 carry, 25 twos are 50. 50 plus 2 is 52. It becomes 525 divided by, with the help of this exponential law, we can write it as 2 raised to 3 into 5 raised to 3. The 3 power as it is 2 into 2 into 5, it is nothing but 2 5s are 10 raised to 3. 10 raised to 3. 10 raised to 3, right? So 525 divided by 10 raised to 3 is nothing but 1000. So 525 divided by 1000 means 0.525. If you are dividing 21 by 40, you will get the same answer. Without doing any calculation, we will find the decimal expansions. This will make a calculation will be simple. Okay. In this method, we are not dividing 21 by 40. With the help of the prime factorization and with the help of the exponential laws, we will simplify and find the decimal expansion of the given number, that is 21 by 40. Okay. See the next question. Second one is 231 divided by 125. 231 divided by 125. So now make the calculation fast. 125 is the denominator value. Just factorize the denominator value. 5 25s are 5 5s are 5 1s are. So 231 divided by 125 can also be written as 5u cube. So if it is in the form of 2 raised to n or 5 raised to m, so it is obviously terminating value, right? It is terminating value means we need to equate the one more value, that is 2 raised to 3 here, where one more term is missing, that is 2 raised to 3, because whenever we are going to be represent the rational number in the form of the decimal expansions, that should be in the form of 2 raised to n and 5 raised to m. So 5 raised to 3 we already have, but one missing term is 2, that is 2 raised to 3. I multiply the same term for the numerator also, right? Once I multiply 2 raised to 3, what I will get here? Bases are different. Bases are different with common powers means 5 2s are 10, 10 raised to 3. Now 231 into 2 cube means 2 2s are 4, 4 2s are 8. Multiply this to what you will get? 8 1s are 8, 8 3s are 24, carry 2, 8 2s are 14, 14 plus 2 is 16 divided by 10 raised to 3 means 10 cube is nothing but 1000. So the decimal expansion of this number is 1.648. It's the simplest method to identify the decimal expansion of the any rational number. If it is terminating means we can easily calculate the decimal expansion. Sorry, here 8 2s are 16, 16 plus 2 is 18, right? So it becomes 1.848. Okay, see the next question. Third one, 7 by 8. 7 by 8. Find whether the given number is terminating or not. If it is terminate, then write the decimal expansion of the given number. So denominator, in the place of denominator what we have? 8. So just factorize the 8. 8 4s are 2 4s are 8, 2 2s are 4 and 2 1s are. So 8 can also be written as 2 raised to 3. 1 2 3. It can also be written as 2 raised to 3. So which term is missing here? 5u cube. Means we need to equate the m and n value, because the rational numbers, the terminating rational numbers are always in the form of 2 raised to n and 5 raised to m. In that we need to equate m and n values. So same number multiply for both numerator and denominator. Now bases are having different values 2 and 5, but powers are same, means and the bases are different with common powers. We multiply the bases and write the power as it is. So 2 5s are 10, 10 raised to 3, right? 7 write as it is. 5 cube is 5 5s are 5 cube, means you need to multiply the 5 3 times. 5 5s are 25, 25 5s are 125. Now multiply these two, what you will get? 7 5s are 35, carry 3, right? 7 5s are 35, carry 3, 7 2s are 14, 14 plus 3 is 17, carry 1, 7 1s are 7, 7 plus 1 is 8, divided by 10 cube is nothing but 1000. 10 cube is nothing but 1000. So 875 divided by 1000 means the required decimal value is 0.875. This is the required decimal expansion. Okay, so these are the some examples. Now I will take one different examples, whether it is terminating or not. Check the given rational number is terminating or not. Fourth one, 11 by 24. 11 by 24. In the place of denominator, what is the denominator value? 24. Just prime factorize the 24. 2 12s are, 2 6s are, 2 3s are, 3 1s are. So this 11 by 24 can also be written as 11 by 2 raised to 1 2 3, 2 raised to 3 into 3. Is it terminating or non-terminating? The given rational number 11 by 24, is it terminating or non-terminating? Can you guess it? Is it terminating or non-terminating? It's the purely non-terminating value. Why? Because the denominator is not in the form of 2 raised to n and 5 raised to m, right? Or it is not in the form of 2 raised to n only, or it is not in the form of 5 raised to n only. It have one more prime number, that is 3. It has one more prime number, that is other than the prime numbers 2 and 5. 3 is the prime number which is other than these two prime numbers. So these type of the decimals or these type of the prime factorization are non-terminating. Okay, means if a rational number in that the denominator, when we are going to be factorize the denominator, it must and should be in the form of 2 raised to n or 5 raised to m, or both 2 raised to n and 5 raised to m. Then only the given rational number is to be considered it as a terminating expansion, terminating value. If I am getting any other value other than 2 and 5, then that rational number is the example for non-terminating, because the 24 has a factor 3 which is other than 2 and 5. Okay, next we come to the next concept, that is non-terminating. Now we are getting some ideas about the terminating and non-terminatings. Okay, non-terminating means, terminating means we are getting the exact value of the rational number. We are getting the exact value of the rational number. It means when we are dividing the numerator by denominator, the numerator will be completely divides by denominator without leaving remainder. But in non-terminating, some digits will be repeats, some digits will be repeats, or some group of the set of the numbers also be repeats. So these kind of the repetitions are called as a recurring numbers. So the next concept is non-terminating. non-terminating. This non-terminating is also we called as a repeating or recurring decimals. Repeating or recurring decimals. A decimal in which a digit or a set of the digits is repeated means then that kind of the rational numbers are called as non-terminating expansions. For example, if I am taking 1 by 3, just divide the numerator by the denominator 3. 1 is the numerator, it is divisible by the denominator 3. 1 is not divisible by 3 means I am taking the point, it becomes 10. 3 3s are 9. What I am getting now? 1, again 10. 3 3s are 9, again 3. 1 is the remainder. 10 3 3s are 9, remainder is again 1. 3 3s are 9, remainder is again 1. So these kind of the repetitions are called as a non-terminating, right? In these types of the decimal expansions, we already know that this is the divisor and this one is the dividend, this one is the remainder and this is the quotient. In these type of the non-terminating rational numbers, we are getting some reminders as well as the quotient value is in the form of repetition of the single digit number or repetition of the set of the numbers. Okay, so these type of the rational numbers are called as a non-terminating rational numbers. Now I will take some examples for the non-terminating values. The first one is 2 by 3. The 2 by 3 which is equal to 0.6666. It is in the continuous form. Second one, 3 by 11. 3 by 11, when I divide 3 by 11, I will get 0.272727. It is in the continuous form. Third one, 15 by 7. When I am dividing 15 by 7, I will get 2.142857, 142857, and the series will be continuous. Here, just observe the decimal quotient, decimal expansion of the quotient, that is 0.6. This 0.66666. Here 6 is a repeated. 6 is a repeated period. This repeated numbers we are called as a repeated periods. We are denoting with the bar, or sometimes we are denoting like this also by indicating dot. This dotted point or bar, what we are writing above the number, no, it indicates this number will be repeat in the next continuous series. It means 0.27. If I put the dot in these two numbers, means the two digits will be continuous. Here you are observing 272727. So these two dotted points will indicate these two numbers, these two digits will be continuous in the sequential orders. Next, in third example, 2.14287. So these numbers you are observing here, 2.142857. The same number is repeated here. 1414285 2857 2857, right? So these numbers are representing in the form of 2.1428557. Here these numbers 14287 are the repeated sequential numbers. Okay, Next one, okay, see the one more example, that is fourth one, 11 by 6. In that, when I am dividing 11 by 6, I will get as a 1.8333. Here 1.83 is the repeated number. So the length of the period, the repetition of these numbers, these decimals, we are called it as the length of the period. And the repeated in non-terminating rational numbers, if the digits, either it may be a single digit or the two digits, here two digits are repeated, here single digit is repeated, here two digits are repeated, here the group of the digits or set of the digits are repeated. So these type of the repeating decimal numbers are called as periods, or circulating recurring numbers, or recurring decimals. Repeated numbers, what we are getting in the decimal expansions, no? So the repeated numbers are called as the repeated decimal expansions are called as recurrings, or periods, or circulating decimal numbers. Circulating means the same number will be comes again and again. So these are the, here 6 is the period of the decimal expansion. In that 2 and 7 are the period. Here 6 is the period. 6 is the period of the decimal expansion. Here 2 and 7 is the period of the recurring number, or 2 and 7 is the period of the decimal expansion. In that, in third one, 1.142857 are the recurring numbers, recurring decimals. In this one, 3 is the recurring numbers. We are usually representing the recurring numbers or repeated numbers in non-terminating value with the help of the bars or dotted points. Okay. And one more, the main concept is length of the period. Length of the period means after how many digits it will be repeats. For example, in first example, you are observing when I am dividing 2 by 3, here 6 is repeated continuously. It means the length of the period is here 1. Because after one digit only it repeats same number. But here the length of the period is 2. The length of the period is 2 because first number is 2 and second number is 7. So 2 and 7, 2 and 7, 2 and 7. After 2 numbers, it will be circulates the same pattern 2 and 7, 2 and 7. Like that, the length of the period number is 2. Here the length of the period is 6 because once these 6 digits complete means the same number of the sequential will be repeats here 1, 4, 2, 8, 5, 7. Next number again 1, 4, 2, 8, 5, 7. So like this, once a set of the 6 numbers is completed means that same set will be repeat one more time like that. Okay, here the repeated number is 3. So these kind of the repetition in the non-terminating decimal expansions, the repeated number or a set of the numbers is called as the length of the periods. It is a number of the repeated values. It is a number of the repeated values. How many times it repeats. It indicates how many times that number will be repeats in the decimal expansion of the rational number. Okay. In the next class, we will discuss some more example based on these terminating and non-terminating, and we will discuss the one more concept, the important concept, that is we are going to be converting the decimals as a rational numbers. We are converting the decimals. For example, if 0.6666, it is in the decimal form. No, we are converting this decimal expansion to the rational number. That is the main concept and important concept we will discuss in the next classes, next sessions. Until then, be happy, have a nice day. Thank you for watching.